We're going to do some more multiplying of polynomials, but we're going to look at some special products. We're going to look at these three: square of a sum and difference, and then difference of squares. And you can multiply like normal, but these have some special patterns that help us to multiply faster. And in the next part of this chapter, when we're doing the opposite and we're factoring, which is undoing the multiplying that we're doing, memorizing these shortcuts and these patterns will help you factor faster as well. So square of a sum or difference, that just means we have, for example, I have 2x plus 5 squared. That means that I have 2x plus 5 twice. And then you do your distributive property, do your multiplying like normal, but they have a special pattern for the solution. So the solution is always going to be whatever this first number is, you just multiply those together, or you square that. So 2 squared and x squared is 4 and x squared, or 2x times 2x. And then for the last number, you multiply the last numbers here, 5 and 5, and that's 25. And then for the middle number, you multiply these two together, 2x times 5, which is 10x, and then you double it. 10x doubled is 20x. Okay, again, you don't have to memorize the shortcuts, but it helps get to the answer faster. And then with the difference, it's the same thing, except it's a minus sign in here. So then that would be 2x minus 5 and 2x minus 5. And then the same things, you're going to take the first number times itself, so 2x times 2x is 4x squared. Take the last number times itself, negative 5 times negative 5 is 25. And then you multiply these two together, 2x times negative 5 is negative 10. Double that is negative 20. Double means times it by 2. Or you could multiply like normal. And then the difference, actually let's just go ahead and do these examples first, and then we'll come back and do the last vocab word. So let's multiply a couple out like normal, and then we'll use a shortcut. So x plus 3 squared means I have x plus 3 times another x plus 3. And then we can just do that distributive property. So we take x times x is x squared, x times 3 is 3x, and then we multiply and distribute the 3. 3 times x is another 3x, and 3 times 3 is 9. And we combine those like terms. So it's going to give me x squared, 3x plus 3x is plus 6x, and then plus 9. So multiplying like normal, just knowing that when I have this squared, it means I just have to write it twice. So we can do another one like that. So again, this means x plus 7 times another x plus 7. Then I can distribute like normal. So x times x is x squared, x times 7 is 7x. Then we distribute the 7. 7 times x is 7x, and 7 times 7 is 49. And we combine those like terms. So we end up with x squared plus 14x plus 49. So if we look for those shortcuts then, and we'll use a shortcut in the last one, I take this first number squared, x squared is x squared. I take the last number there, squared, 3 squared is 9. And then you multiply these two together, x times 3 is 3x, double that or times it by 2, and you get 6x. I'm going to do it here. X times x is x squared, 7 times 7 is 49, multiply them together, x times 7 is 7x, times that by 2, 14x. So let's do the shortcut on this one. 2x times 2x is 4x squared. 4 times 4 is positive 16. And then to get the middle number, we multiply these two together. 2x times 4, that's 8x. Double that, so times that by 2 is going to be 16x. And then for number 4, then we're going to use that shortcut to help us figure out what these numbers must have been. So this first number comes from the first value here. So what number times itself would be 25? And that is 5. So this must have been 5x. And the last number comes from here. So what number times itself is 36? And that would be 6. And then with the minus sign, it's going to be the same. If we look back up into our problem up here, if this is a plus sign, then this is a plus sign. If this was a minus sign, then this is a minus sign. but that is the only difference. So let's do one of these written out, and then we'll do the shortcut on the other two. X minus 5 times another x minus 5. That's what it means to be squared. It means there's two of them. And then we distribute. X times x is x squared. X times negative 5 is negative 5x. And then we are done with the x. We distribute the negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. Then we're going to combine those like terms. That's going to be negative 10x plus 25. All right, so then let's use a shortcut for the next two. But again, you could just write them out. So I'll write this out, but then I'm going to use a shortcut. So this would be the same thing as x minus 8 times another x minus 8. So I could do all that distributive property. But let's use a shortcut. So we take the first number, times it by itself, so x times x is x squared. We take the last number, negative 8, multiply by itself, so negative 8 times negative 8 is positive 64. And then we multiply these times each other. X times negative 8 is negative 8x. And then you double that, so times it by 2 is going to be negative 16x. And then we've got our answer. If you distribute this all out, we end up with that same problem. Let's use a shortcut again on number 7. So we take 3x times itself, so 3x times 3x is 9x squared. And negative 2 times negative 2 is positive 4. Then we multiply these times themselves. 3x times negative 2 is negative 6x. Double that, so times it by 2, and that's going to be negative 12x. And then we can use that pattern here. So 16 comes from what number times itself? It would be 4. And 9 comes from what number times itself? And that's 3. So let's talk about this. If we start here, how could we tell that it comes from a problem like this? If this is a perfect square, 16 is 4 times 4, and this is a perfect square, that's 3 times 3. And then you can always check the factors here. 4 times 3 is 12, double it, 24. Doubling it should equal the middle one. And we'll do more of that backwards when we get to the next part of the chapter. Okay, the next one. Let's go ahead and multiply this out. So these, if you notice, are all very similar. They both have an x and a 4, but one's a plus and one's a minus. They both have an x and a 6 for number 10, but one's a plus and one's a minus. And number 11, they both have a 5x and a 2, but one's a plus and one's a minus. So let's see what happens when we do this distributive property. X times x is x to the second. X times negative 4 is negative 4x. And then we do the 4. 4 times x is 4x. And 4 times negative 4 is negative 16. But then when we combine these like terms, we're going to keep the x squared. Negative 4x and positive 4x makes 0. So that term just goes away because it's 0. Then we still have the negative 16. So when we have problems like this where they're almost the same, but one's plus and one's minus, they're going to cancel each other out. So then the shortcut, and let's write it up here. If I have, let's give it an actual number. So if I have 5x plus 3 and 5x minus 3. So we're going to multiply the first number by itself. So it's 5x times 5x is 25x squared. We're going to multiply the last number by itself. 3 times 3 is 9. And then the middle term we know will cancel out. And you just want to have a negative sign here. And we can tell because this is going to be a positive 3 times a negative 3, which makes it always negative. Okay, so let's try using the shortcut for number 10. So we're going to multiply x times x is x squared. Then we're going to multiply 6 times negative 6 is negative 36. And again, the middle term will cancel itself out, so we don't need to write it. Same thing here. 5x times 5x is 25x squared. 2 times negative 2 is negative 4. And then if I had done this distributive property, it would be like this, where we're going to have those middle terms are going to just make 0 and cancel each other out. So then let's look at our example here and work backwards. 4 comes from what number times itself? And that'd be 2. So then this is a 2, and this is a 2. 81 comes from what number times itself? And that'd be 9. So this was a 9 and a 9. And then notice one's a plus and one's a minus. But remember, you do not have to use these shortcuts. You can always do like we did here and do your distributive property, combine your like terms, and get your solution. Same thing for this kind up here. Do your distributive property after you write out the problem. Combine your like terms, get your solution. So you do not have to remember these shortcuts. But if you do, you can solve this a lot faster.